Hello everyone, so this is the third video in the question series, and this is supposed to be one of the more difficult questions. So let's get started. So reading from the last sentence, we're looking for ejection fraction here. It's always nice to read the last sentence first, as it gives us an idea for what keywords we should be looking for in the question stem. So in here, ejection fraction, this has a formula, so I'm going to be looking for numbers to plug into the formula. So this makes the first 2 or 3 sentences unimportant, as they do not have any values that could be plugged into the ejection fraction formula. Alright, so starting with the first number, the heart rate is 100, blood pressure is 180/90, and the systemic vascular resistance is 40. And we have the end systolic volume, which is 70. So before I proceed to answer this question, I would recommend that you guys pause the video and give this a try, and resume when you're ready. Alright, so we're looking for ejection fraction, and so the first thing I would want to do is write down the ejection fraction formula, which is stroke volume over end diastolic volume. Another way we could write this is end diastolic volume minus end systolic volume over end diastolic volume. This is because the stroke volume is equal to the difference between the blood volume you have at the end of diastole and the blood volume you have at the end of systole or contraction. So this represents the blood that's ejected, the volume of blood that's ejected out of the left ventricle into the aorta. So the only value we have that's given is the end systolic volume, and this means we're going to have 2 unknown variables. So we can't solve using this formula. So what other formulas could we think of that bring the variables that are given in the stem together into one formula? Okay, so we have the heart rate, blood pressure, SVR. Okay, there's one formula, the cardiac output equals stroke volume. So if we actually figure out the stroke volume from this formula, we could plug it into this formula here, and we'll have just one unknown end diastolic volume, and it will be easy to figure it out. So that's stroke volume, so cardiac output is stroke volume multiplied by the heart rate. But unfortunately, again, we're going to have 2 unknown variables. We only have the heart rate in here, which is 100. Okay, so we could try and figure out another formula that would give us the cardiac output. So we're given the heart rate, blood pressure, SVR. So we could write down P equals QR. This is mean arterial pressure equals flow or cardiac output multiplied by the resistance. So we have the blood pressure and we have the systemic vascular resistance. And when I saw SVR here, 40, I immediately thought of this formula actually, because this is like, I think this formula, there are only like 2 formulas on step 1 and 2 that you should know that have resistance. So yeah, in here, this formula brings the blood pressure, cardiac output, and resistance together. So the mean arterial pressure, by the way, P here is mean arterial pressure, okay? So we're going to have to convert the value that's given here into mean arterial pressure. So the formula for mean arterial pressure is 1/3 the systolic blood pressure plus 2/3 the diastolic blood pressure. And this is because in one cardiac cycle, the heart spends 1/3 of the time contracting and 2/3 of the time relaxing in diastole. So in this case, 1/3 of 180 is 60, and 2/3 of 90 is also 60. So this makes the mean arterial pressure 120. And now we could plug it into the PQR formula. So we're gonna have, so we're gonna have 120 equals Q times the resistance, which is 40. So this means that Q equals 3. Okay, so now we have the cardiac output. Flow is cardiac output, okay? And in this case, it's measured in liters per minute, okay? Because the SVR had liters in the unit, and the heart rate is also per minute, okay? And usually cardiac output is written in liters per minute. So now we could plug it into the cardiac output formula here. As we have two known variables, that's the cardiac output and heart rate, and we should be able to figure out the stroke volume from here. So, okay, by the way, guys, stroke volume is usually measured in milliliters, and the end diastolic and end systolic, as they gave us here, is written in milliliters as well. So it would be easier if we convert the cardiac output into milliliters, which would be 3,000. Always make sure your units are constant. So here, here this is gonna make the cardiac output 3,000 equals stroke volume times heart rate is 100, which means that the stroke volume is equal to 30 milliliters. Okay, so that's consistent with the value we have here, the end systolic volume also in milliliters, with the unit, sorry, we have in the question stem. So now we have the stroke volume and the end systolic volume, okay, and we said that we need, if we have only one unknown variable, we could figure out the answer. Yeah. So here we have stroke volume and end systolic volume, and now we could figure out the end diastolic volume. So if we plug in the numbers, the stroke volume is 30. So EDV minus 70, sorry. This means the EDV is 100. So now we could plug in, now we have all the values we need to plug into the ejection fraction formula. So going back to the first formula, the stroke volume we said is the stroke volume is 30, we said, and the end diastolic volume we said is 100. Okay, so 100 here. So this makes the ejection fraction equal to 30%. And so E is the correct answer. So yeah, guys, this is definitely a tough question, and you might want to watch the video again, as there are so many formulas that you have to know to answer this question. And always write down the formula for each step. So for example, in this case, the first time I saw ejection fraction, I immediately wrote down the formula, and then I figured out, okay, I have two unknown variables. What other formulas could I think of that could give me one variable in the ejection fraction formula? So stroke volume, for example, is one of the unknown variables in the ejection fraction formula. So I thought of another formula that has stroke volume in it. So that's the cardiac output equals stroke volume times heart rate. Again, I realized, okay, we have two unknown variables, the cardiac output and the stroke volume. So what other formula could I think of that has stroke volume or cardiac output in it that would help me figure out the answer? So that's P equals QR. And this one works in here because we're already given the blood pressure but we just have to find out the mean arterial pressure, and we're also given the resistance. And so from this formula, we could figure out the cardiac output. And then once we figure out the cardiac output, we could plug it into this formula here to figure out the stroke volume. And then when we find the stroke volume, we could go back again and plug it into this formula here to figure out the end diastolic volume, and then finally go back to the first formula and plug it into the ejection fraction formula to figure out the ejection fraction. So yeah, guys, I hope you found this helpful, and thank you for watching.